Here, hello everyone, and welcome to this video lecture on the basics of digital image. In this session, we'll take a journey through foundational concept beyond digital images from types, structure, and representation to compression. Let's begin. Here is a quick overview of what we will cover in this presentation. We will start by understanding a different types of images and then explore how digital images differ from analog ones. We'll dive in deep into the structure of digital images, pixel concept, bit depth, resolution, and finally discussion image compression. Right. Here in this slide, we'll discuss the types of images. Images can be broadly classified into two types: analog image and digital images. Analog image and digital image. Usually, analog images are continuous in nature, like photographs on film, while digital images are made up of discrete elements called pixel. Like this, there are numbers. It will be stored in the form of matrix. It will be understood by users. Right. Once you understand that, let us understand the advantages of the digital images. Digital images provide a significant advantages over analog. They are easy to store, edit, and transmit, and reconstruction of any images or reformatting and analyzing using a computer system. This digitization enables the greater control and repeatability and precision, which are all is very significant advantage while using a digital images. Let us look at the analog image. Analog images consist of continuous level of brightness or color. They are captured and viewed by human systems and represent smooth variation without discrete steps. So there is a continuous waves, continuous signals. Look at this, continuous signals. There is no discrete way of variation among these analog images. Human can be viewed, but in terms of view by computer system, it is very tough. So, but whereas in digital image are represented as a matrix of pixels, like this matrix of pixels, right, where each pixels holds a numerical value. Each pixel holds a, if I take a small pixel, take over it, I will represent it here. It is values corresponding to brightness or colors. These are designed for computer processing and manipulation. So otherwise very difficult to process by computers. Always the any pictures are converted into matrix of pixels. These elements are called as pixels. Right? Then a contrast, a computer uses a two structure of digital images or like this is like a computer use only binary digit, just two digits are there. It can represent zeros and ones. These binary digits are bits, form the foundation of digital data. That is the major advantage of using a digit. Look at this, entire image is converted into a matrix of pixels. These pixels are like pixels are represented in terms of zeros or ones. Right. So how do you represent these values? How do you represent these values? To represent the number digitally, use the combination of bits. Use the combination of bits. Right? So this combination, humans use the decimal number system which has 10 digits. Look at this, 10 digits. 0 through 9. Each place a number as a value based on power of 10. Look at these numbers. Each of these values are represent. There is a human can refer this unit ones, tens, hundreds, and thousands. Each position have its own values, right? Represented in in the human number system. Whereas so human can write a comparing. There is a comparing. The in contrast, computer uses a binary digits. There is two different. They are comparing human and computer digits. Human can write. There is a values between 0 to 9. Values between 0 to 9. But we have a 10 different digits. But how computer can write it? So computer can write it only two values. In this, there is a color coded is here. The white color is represented value 1 and black color it is represented 0. So there is zeros and ones it will represented by systems. So that means, so there is, we'll be writing like this. Okay, two different digits. Two different digit, it is like a binary digit. So how do you write a numbers in bytes? To represent number digitally, use the combination of bits. For example, using a 4 bytes. Suppose if I want to use to represent, we can 4 bytes of values, which gives up to 16 different values, like 0, 0, 0 to 1, 1, 1, 1. That indicates that it is start with 0 to 15, right? So 16, right? So suppose look at these values, what will be representing? How do you write in the binary value? So as you told in the previous slide, that white is indicated 1, black is indicating 0. So again white and 0, right? So this value, okay, it is a value. So indicating that 1, 0, 1, 0. So that value is indicating 5, right? So again this value is indicating 0, 1, 0, 0. That means it is a 11, right? It is 1, 1, right? This like this can be representing it. So there is, how do you represent a range of values for numbers in binary form? As the number of bits increases, so does the number of values can represent for instance. For instance, 8 can represent 256 values from 0 to 255. Like that it can represent. Look at this. So this 0, it is indicated 1. So this indicate not, just confuse that. Here it is, this is a 0, this is 1, this is 0, this is 1, right? This indicate 5. Here it is 1, this block indicate 1, this blank indicate 0. So this 0, 0, 1, that means it is indicate 1. Similarly 1, 0, 1, 1 indicate 11. So binary number system, you can write it like this. In this case as well, so there is, so any values are representing like 0 to 255. Okay, so this indicate like your way of writing the binary values from 0 to 250. Right. So let us move on to understands pixel bit depth. What do you mean by pixel bit depth? Pixel bit depth determines the number of brightness or colors levels a pixel can store. Higher bit depth means more shades and better image quality. So there is the bit depth is very important for maintain the quality of images where we have the more depth of shades are available, that image quality will be better as compared to the depth is less. Right. Let us move to the further to understand the pixel bit depth. Suppose you have a 8-bit pixel depth. How do you represent? So 8-bit can have a 256 different shades, right? You can write it like this. Bit depth determines that, right? An 8-bit pixel can store, as you told, 256 shades of gray. This level of detail is common in grayscale images and often sufficient for image human perception. Human perception. Right. I hope you understand this. This will be pixel depth. It is starting with 0 to 255. This depth is indicating these are the pixel values. Suppose their values are, suppose they have 8 bits, that equivalent to 1 byte of pixel image, right? So then what will be the effect of bit depth on the image? Images with low bit depth may appear lack a smooth gradient. Increasing the bit depth enhance the visual quality by allowing smoother transition between the tones. Look at that, there is a bit depth gradient is very less in this, bit depth is are more, there is visibility is more. If you have still better compared to the previous one, there's where we have a 2 shades, the gradients, smooth gradients, lack of smooth gradients, right? It's not visible, but where we have the more shades, then visibility is more. This all indicating number of per pixel, bits per pixels in each of the images, which is the indicate how you can utilize the depth of the image, bit depth of the image, and their effects. Then the size of each pixel affects detail, image detail. A smaller pixel captures finer detail, while larger pixel may cause blurring or loss of sharpness. Look at here, where they have a smaller pixels, you have a clarity, you have clear clarity. Where there are larger pixels, the blurriness and lose the sharpness, which affects factors pixel size and image details. The pixel size depends on two things. One is size of the image. Size of the image is nothing but sensors or display area. Another one is the matrix size. Matrix size, the number of pixel in the matrix, right? So that is the way you have to conduct. How do you calculate the pixel size? So the pixel size is nothing but image size and image size sensors, that is a display area, divided by matrix size, the number of pixels are represent to the image, right? So then for the same pixel, right, for the same physical image size, If I take the same physical image size, this size will be same, right? Rows into columns. This also same, right? Increasing the matrix size reduce the pixel size. So if we want to increase the matrix size will be increasing, the pixel size will be reduced. Pixel size will be reduced, resulting in better detail. You keep on increasing the matrix size, the pixel size will be increases. Pixel size increases, you will get better detail. Conversely, a smaller matrix leads to larger pixels. The pixel size is more and less detail will be visible to the system, human beings. In this, what will be effect of field of view on digital image detail? A wider field of view spreads the pixel over the larger area. When you take this size, I take out that part of image pixels over the larger area, potentially reducing the detail, which will reduce the detail. A smaller field of view concentrate the same number of pixels into smaller area, which improves the image details. So then numerical size of digital image. The file size of digital image depends on its resolution and bit depth. For example, you need to store the value, the image resolution will be 1024 into 1024, which requires 8-bit pixel will occupy 1 megabit space. 1 megabyte of space. Okay, you need to store this size of the image, which requires 1 megabyte of space. Right. Then, and come to the compression, image compression. Compression helps to reduce the image file size for storage and transmission. Lossless method. There are two types of image compression. One it is called lossless method. Another method is called lossy method. In lossless methods, which retains all data, will not losing any information, while lossy methods remove some detail to save space. So better example here, you can use the JPEG and PNG formats respectively, right? So look at that. This quality will always lossless will improve it. It will not be losing any information. It will retain the 2 megabytes of byte. So image quality is more clear. Whereas lossy method, you losing some kind of information to in order to reduce the space, which occupies the space only 0.08 megabytes, but clarity goes on. Okay. So with this, I hope you understood this basics of image processing. And thank you. That wraps up your session on the basic of digital image. I hope this helped you understanding how digital images works and the key parameters that affect their quality. Thank you for watching. Thank you. Thank you for your patience.